Welcome to Meteorology Matters. Today we're going to take a very close look at Hurricane Milton, a
Yeah.
truly remarkable storm
Definitely remarkable.
that impacted the Gulf of Mexico and Florida back in October 2024.
Yeah, October 2024. A lot of people remember that one.
Our information today comes directly from the National Oceanic and Atmospheric Administration's National Hurricane Center.
Yep, straight from the source.
And we have a very, very detailed report here covering every aspect of Milton from its initial beginnings way out in the Atlantic
Way out there.
to its eventual dissipation.
Right.
And, of course, a thorough analysis of its meteorological characteristics and the significant impact that it had on coastal communities.
That's right. Yeah. All the data is here.
Absolutely. So we've got a wealth of information here to unpack.
Yeah, we do.
The entire life cycle of the storm, those detailed meteorological readings, the effects that were felt on the ground, and even a look at the challenges that the forecasters faced. Our mission today is to really extract the key insights from this complex event and really try to understand what made Hurricane Milton so noteworthy.
Yeah, that's the goal. What made it so unique?
And if you find this kind of deep dive into meteorology fascinating, be sure to follow meteorologist Rob Jones on Instagram, meteorologist, on TikTok, TV meteorologist, and on YouTube, follow Rod Jones Hurricane, where you can also find the Meteorology Matters podcast playlist.
Absolutely. Great resources.
Okay, so let's start at the very beginning.
Right.
Milton's birth was quite complex, involving multiple tropical waves that originated off the coast of Africa back in mid-September 2024.
Yeah, the National Oceanic and Atmospheric Administration report notes that the initial wave emerged, around September 14th or so, and it didn't show much in the way of organized thunderstorms, or what we call convection.
Right.
But what's interesting is that the interaction of this wave with a pre-existing low-pressure system near Cabo Verde, that group of islands off the coast of Africa, that interaction seems to have been a crucial first step in giving the storm some initial structure.
So it needed that boost, that extra little push.
It seems like it, yeah.
And then just a few days later, around September 18th, a second tropical wave moved off the African coast. And it looks like this second wave acted as a real catalyst, leading to a more defined wave by September 22nd as it tracked westward across the Atlantic.
Right, so now you've got these two waves kind of merging, and that creates a more significant area of atmospheric instability and rotation, the ingredients you need for something bigger to form.
Yeah, it's like these initial atmospheric ripples needed to combine in just the right way to really get things going.
It's a bit like that, yeah. Sometimes you need more than one ingredient to start a reaction, right?
Yeah, exactly.
And this is a great example of how these seemingly independent weather disturbances can merge and set the stage for something much larger.
Really is fascinating.
It is.
The report notes that this combined wave reached the Lesser Antilles around September 26th, bringing increased but still disorganized thunderstorm activity.
Right.
Then it kind of meandered across the eastern and central Caribbean Sea for a couple of days without any significant strengthening. So it was swirling, but not quite locking in.
Yeah, and that's pretty typical in those early stages. They need to find those right conditions. So you have warm ocean waters, low wind shear, to really start to organize and draw in energy.
Right.
That disorganized convection tells us that those crucial ingredients weren't quite aligned just yet.
Okay, so here's where it gets really interesting for me.
Okay.
When the wave reached the western Caribbean Sea around September 29th, it interacted with this broad area of low pressure, the remnants of what's called the Central American gyre.
Yeah, the gyre.
Now, this gyre had previously helped to spin up Hurricane Helene in the Caribbean and Hurricane John way over in the eastern Pacific.
Yeah.
So this thing had quite a pedigree.
It did.
It's like one big weather system can have these ripple effects across entire ocean basins.
Yeah, that's a great way to think about it.
It is fascinating.
It is. These large-scale atmospheric patterns like the Central American gyre, they can act as steering mechanisms and also create favorable conditions for smaller disturbances to develop.
Okay.
Think of the gyre as a giant, slow-spinning weather system that can sometimes catch these smaller disturbances and give them a spin.
Right.
Much like you see, a larger eddy in a river can affect those smaller currents.
Right.
The National Oceanic and Atmospheric Administration report really emphasizes how significant a role this played in Milton's development.
Wow.
Yeah.
By October 1st, this interaction led to a low-level trough, kind of an elongated area of low pressure,
Right.
extending from the Bay of Campeche northeastward toward the central Gulf of Mexico.
Uh-huh.
Now, this was also interacting with a frontal system over the eastern Gulf.
Yeah, you got a lot going on.
It sounds like a real meteorological melting pot, with different air masses and weather systems all bumping into each other.
Yeah, precisely. You have different air masses with varying temperatures, moisture content, and they're all interacting.
Right.
Sometimes these interactions can inhibit tropical development.
Okay.
But in Milton's case, it seems the remnants of that storm from the eastern Pacific played a particularly important role in jump-starting the process.
So that was really the key.
It appears so.
Right. By October 3rd, a north-south oriented trough formed over the western Gulf. And get this, it had 2 areas of concentrated spin, what meteorologists call vorticity centers.
Yeah, 2 centers of rotation.
The northern one weakened, but the southern center really took off, likely because it interacted with the remnants of an unnamed tropical storm that had crossed Mexico from the eastern Pacific.
Yeah, so yet another factor contributing to Milton's development.
It's almost like that Pacific storm handed off some energy to the developing system in the Gulf.
That's a great way to put it.
Isn't that interesting?
It really highlights how hurricane formation can be this multi-stage process where existing atmospheric disturbances, they can contribute energy and rotation.
Right.
It's not always straightforward.
And so finally, on October 5th, about 135 nautical miles east of Tampico, Mexico, it officially became a tropical depression.
There it is.
The genesis, as the National Oceanic and Atmospheric Administration report clearly shows, was a rather involved and multifaceted process.
It really underscores just how intricate the birth of a hurricane can be.
Yeah.
With so many different atmospheric players and interactions needing to align in just the right way.
Absolutely.
So now that we've got our tropical depression, let's move on to how it started to move.
Okay.
And more importantly, how it intensified.
Right. So initially, Tropical Depression Milton moved slowly northward through the early hours of October 6th. But then, likely due to increasing air pressure to the north and the continued influence of that front and another nearby vorticity center,
Another one?
it shifted to a slow eastward movement.
Yeah, it kind of got nudged.
It was almost as if it bumped into an invisible wall up north and had to change direction.
That's a good way to visualize it.
That eastward turn was quite notable and somewhat unusual for a storm in the Gulf of Mexico during that time of year.
Yeah, typically, high-pressure systems steer storms westward in that region.
Right.
So the fact that Milton moved eastward suggests a really complex interplay of different pressure systems and steering currents.
Okay. And during this eastward journey, Milton steadily strengthened, reaching hurricane strength by the evening of October 6th, while located west-northwest of Merida, Mexico. So it was gradually gathering strength over that warm Gulf water.
Yeah. The Gulf of Mexico at that time likely had very warm sea surface temperatures. And, that provides the primary fuel for tropical cyclones.
Right.
And coupled with relatively low amounts of vertical wind shear, that's when the wind speed or direction changes significantly with height.
Okay.
So the environment was really conducive for steady intensification.
Right.
It had everything it needed.
But then came the really dramatic changes.
Well, yeah.
Early on October 7th, Milton took a sharp turn to the east-southeast, and this coincided with what the report calls explosive intensification.
Explosive, that's the word for it.
The central pressure plummeted from 977 millibars down to an estimated 895 millibars in about 17 hours.
Wow.
That is an incredible rate of intensification.
It is an 82 millibar drop in atmospheric pressure in such a short period.
Yeah.
That really signifies an extremely rapid organization of the storm's internal structure.
Wow.
The report mentions that the peak sustained winds reached an estimated 155 knots around 8 p.m. UTC on October 7th, while the storm was northwest of Merida.
And get this. That minimum central pressure of 895 millibars tied Hurricane Rita of 2005 for the 4th lowest central pressure ever recorded in an Atlantic hurricane.
It's in some pretty elite company.
We're talking about a storm that at its peak was among the most intense ever observed in this basin.
Absolutely.
Wow.
Only Hurricane Wilma in 2005, Hurricane Gilbert in 1988, and the Labor Day hurricane of 1935 had lower central pressures.
So, earlier I was asking about what specific conditions really aligned for that rapid pressure drop.
Yeah, what came together to cause that?
So can you elaborate on that a little bit?
Sure. So it likely involved a combination of factors.
Okay.
You had those exceptionally warm sea surface temperatures.
Right.
Very low vertical wind shear, allowing that storm structure to organize unimpeded.
Okay.
And perhaps some favorable upper-level atmospheric features that help to vent air out of the top of the storm, further lowering the pressure at the surface.
So everything just really came together perfectly.
It did. It was a perfect recipe for intensification.
But as often happens with these very intense storms,
Yeah.
a weakening phase followed. Hurricane Milton underwent an eye wall replacement cycle while it was tracking eastward near the Yucatan Peninsula.
Right.
This brought tropical storm conditions to the coast, but kept the most intense hurricane-force winds just offshore.
So can I ask, can you explain what an eye wall replacement cycle is
Yeah.
and why it leads to weakening?
Sure. So the eye wall is that ring of intense thunderstorms surrounding the eye of the hurricane.
Right, where you find the strongest winds.
Exactly. In very intense hurricanes, a secondary eye wall can sometimes form outside the original eye wall. When this happens, the outer eye wall gradually contracts inward, eventually replacing the inner eye wall.
Okay.
During this process, the storm structure becomes less organized, leading to a temporary weakening of the maximum sustained winds.
So it has to kind of rebuild itself?
Exactly. Once the new, larger eye wall becomes fully established, the hurricane can sometimes re-intensify,
Sure.
although not always to its previous peak intensity.
So it's not guaranteed.
Right.
Interesting.
So it's like the storm has to rebuild its core.
Yeah, it's a good analogy.
And then starting on October 8th, the movement became quite erratic, shifting east-northeastward.
Yeah, unpredictable.
This coincided with a low-pressure system over the northeastern Gulf, moving out into the Atlantic, and a ridge of high pressure building in.
Oh, wow. So the steering currents were shifting.
It sounds like the atmospheric steering forces were constantly changing.
Yeah, the departure of that low pressure system and the strengthening of the high pressure ridge, they created this new set of forces influencing Hurricane Milton's track, leading to that more easterly and then northeasterly component in its movement.
Yeah.
So you've got the internal reorganization from the eye wall replacement and these shifting external steering forces.
Right.
The storm's path really became quite unpredictable for a time.
Really hard to forecast at that point.
Yeah, definitely. It was keeping the forecasters on their toes.
And sure enough, after that eye wall replacement cycle completed, Hurricane Milton did re-intensify, reaching sustained winds of 145 knots on the evening of October 8th.
Okay.
Followed by more fluctuations in intensity.
Up and down.
This storm certainly kept forecasters on their toes.
It absolutely did. These intensity fluctuations, they can be very challenging to predict accurately.
Yeah.
They depend on this delicate balance of the hurricane's internal dynamics, like those eye wall cycles, and the constantly evolving external environmental conditions, such as sea surface temperatures and upper level winds.
So a lot of things can affect the intensity.
A lot of moving parts.
Then around 6 a.m. UTC on October 9th, stronger southwesterly winds in the upper atmosphere, what we call increased vertical wind shear, caused it to accelerate northeastward over cooler waters.
Right, so wind shear can really disrupt a hurricane.
This led to rapid weakening of the storm, although its overall size actually increased.
Interesting.
So it was losing some of its punch in terms of maximum winds, but becoming a broader storm system.
Okay, so like spreading the same amount of energy over a larger area.
Exactly.
That increased wind shear started to disrupt the hurricane's vertical structure, essentially tearing at its organized core. At the same time, as it moved over cooler waters, its primary energy source was diminishing, leading to that rapid weakening.
Okay.
However, the storm's overall wind field expanded, meaning a larger area was experiencing tropical storm force winds, even as those core winds decreased.
And finally, the climax.
Landfall.
Landfall is a Category 3 hurricane with maximum sustained winds near 100 knots on Siesta Key, Florida, at 12:02 a.m. UTC on October 10th.
So still a major hurricane at landfall.
It had maintained major hurricane status, that's Category 3 or higher, right up to the coast.
Wow.
Which is a testament to its power.
It really is. Landing as a Category 3 hurricane still signifies a very dangerous storm. Capable of causing widespread and significant damage from those powerful winds.
Right.
That substantial storm surge and the heavy rainfall, Siesta Key and the surrounding coastal communities, or the initial brunt of those intense conditions.
Then it continued its northeastward trek across the Florida Peninsula, emerging into the Atlantic Ocean near Cape Canaveral by 8 a.m. UTC on October 10th.
Right.
From there, it underwent what's called extratropical transition, and eventually dissipated a few hundred nautical miles south of Bermuda by March 12th.
Wow, that's a long life.
That's a remarkably long lifespan for a single storm system.
It is.
Can you briefly explain what extratropical transition means?
Sure, extratropical transition is when a tropical cyclone loses its warm core characteristics and transforms into a mid-latitude storm, similar to the nor'easters we see up here in the Northeast.
Okay.
This typically happens when the storm moves over colder waters
Right.
or interacts with strong upper-level winds and fronts,
Okay.
which are more characteristic of those mid-latitude weather systems.
Right.
So it essentially becomes a different type of storm.
So it loses its tropical characteristics.
Exactly.
Okay, now let's dive into some of those key meteorological statistics that really highlight Hurricane Milton's intensity and impact.
Yeah, the numbers tell the story.
The peak intensity, as we discussed, reached Category 5 status with those estimated sustained winds of 155 knots.
Yeah, and that minimum central pressure of 895 millibars, incredibly low reading.
Really is, and even at landfall, it was still a significant Category 3 storm
Right.
with 100-knot winds and an estimated minimum pressure of 958 millibars.
Still packing a punch.
Even after some weakening, it was still a very formidable force.
Absolutely. A Category 3 hurricane can still inflict widespread damage to buildings, infrastructure, vegetation due to those intense winds.
Right.
And it poses a significant threat from storm surge and heavy rainfall.
The highest sustained wind speed reported on land in Florida was 79 knots.
Wow.
With gusts up to 93 knots
Yeah.
recorded at Venice Beach.
So you can just imagine the force of those winds.
That gives you a real sense of the powerful winds that directly impacted the coastline.
It does.
Can you quickly explain the difference between sustained winds and gusts?
Sure. Sustained winds are the average wind speed over a certain period, typically 1 minute.
Okay.
Gusts, on the other hand, are brief, sudden increases in wind speed above that sustained wind.
Gotcha.
So gusts are what often cause more localized and sudden damage,
Okay.
like snapping tree limbs or tearing off shingles.
Okay.
So while the sustained winds give you an overall measure of the storm's strength, the gusts really represent that peak force that structures might experience.
Right, so it's the gusts that do the most damage.
Often, yes.
Then there was the very significant storm surge along the central to southwest Florida Gulf Coast.
Yeah, the surge was a major factor.
The National Oceanic and Atmospheric Administration report indicates surge heights of 6 to 9 feet above ground level from Venice to Boca Grande, with an isolated peak of up to 10 feet near Minnesota Key.
Wow.
Just the sheer power of that much water.
I know, it's hard to imagine.
Inundating coastal areas is hard to imagine.
It is, and storm surge, that abnormal rise of water generated by a storm, is often the deadliest and most destructive aspect of a hurricane.
Yeah.
These inundation levels, they can cause catastrophic damage to homes, businesses, infrastructure, located in those low-lying coastal regions.
Right.
And the report also makes an important point that the actual height of the waves on top of the surge would have been significantly higher,
Wow.
leading to even greater impacts.
And the rainfall totals in some areas were just extraordinary.
The rain was relentless.
The maximum recorded in Florida was a staggering 20.40 inches
Wow.
near St. Petersburg,
That's a lot of rain.
which led to widespread river and urban flooding,
Oh, yeah.
including record high water levels on the Hillsborough River.
Yeah, such high amounts of rainfall over a relatively short period can quickly overwhelm those drainage systems,
Right.
leading to significant freshwater flooding. This can occur far inland from the coast
Right.
and cause substantial damage to property and infrastructure, as we saw with those record river crests.
Absolutely. And there was also a pocket of very heavy rain near Vero Beach, with over 11 inches reported.
So widespread heavy rain.
But perhaps one of the most notable and sadly destructive aspects of Hurricane Milton was the very significant tornado outbreak that occurred over southern and central Florida on October 9th.
Yeah, the tornadoes were a big part of the story.
The report documents an astonishing 45 confirmed tornadoes on land,
45, that's unbelievable.
as well as one waterspout.
Yeah, that's an unusually high number of tornadoes associated with a single tropical cyclone.
Really is. It's not something you see every day.
No, not at all.
In fact, the National Oceanic and Atmospheric Administration report highlights that Hurricane Milton was the first tropical cyclone on record to produce more than one EF3 tornado.
Wow.
So that's a significant and concerning statistic.
It really is. And tornadoes spawned by hurricanes,
Yeah.
they're often relatively short-lived
Okay.
and can be very difficult to predict with precision.
Right.
However, as we tragically saw with Hurricane Milton, they can really significantly increase the overall damage. and pose a very serious threat to life, particularly from those stronger tornadoes like the EF3s.
And we saw 3 EF3 tornadoes,
Yeah.
6 EF2s, 25 EF1s, and 7 EF0 tornadoes.
So a range of intensities.
Tragically, the strongest EF3 tornado, which struck near Fort Pierce in Vero Beach, caused fatalities.
Yeah, a very sad outcome.
Adding another layer of devastation to this event.
So now shifting our focus to the human impact.
No.
The casualty and damage statistics really paint a stark and sobering picture of Hurricane Milton's consequences.
They certainly do. The report confirms 15 direct deaths attributed to the storm, 12 in the U.S.,
Right.
all within Florida.
Right.
And these included fatalities from the tornadoes, falling trees, and flooding.
Yeah, the storm surge.
In Mexico, there were 3 direct deaths reported
Okay.
due to dangerous high surf conditions and a boating accident.
Right. Sadly, 6 people were also reported missing from a fishing boat off the coast of Mexico.
So the impact was felt in both countries.
It was a wide-reaching event.
And beyond the immediate and direct fatalities, there were 27 indirect deaths reported in the U.S., again, all in Florida.
Yeah, the indirect impacts can be significant as well.
These tragic incidents were linked to various factors, such as health issues experienced during that intense preparation and cleanup phase, falls, car accidents, hazards from downed power lines,
Right.
a fire that was started by storm surge,
Oh, wow.
and even a fatal injury from a falling tree limb after the storm had passed.
So the dangers can persist even after the storm is gone.
It really underscores the long-lasting and far-reaching dangers associated with such a major hurricane event.
Absolutely.
The estimated total damage in the United States reached a staggering $34.3 billion,
$34.3 billion, that's hard to fathom.
with almost all of that devastation occurring within the state of Florida.
Wow.
The National Oceanic and Atmospheric Administration report also notes that conducting accurate damage assessments was made more complicated by the fact that Hurricane Helene had impacted some of the same areas just 2 weeks prior.
Oh, wow. So back-to-back hurricanes.
That must have significantly hampered recovery efforts for those communities.
Yeah, the cumulative impact of experiencing 2 significant hurricanes in such close succession can be truly devastating for these regions.
Right.
It really strains resources, complicates recovery logistics, and can have a profound and prolonged impact on residents and the local economy. That immense financial toll of $34.3 billion really highlights the significant economic consequences that these powerful storms can inflict.
Yeah, absolutely.
One particularly striking example of the damage was to Tropicana Field in St. Petersburg,
Oh, yeah, I remember hearing about that.
where a significant portion of the fabric roof was ripped off by those intense winds, leading to substantial water damage inside the stadium.
Wow, it's a vivid reminder of the sheer force of hurricane-strength winds.
It is a stark reminder of nature's power.
Now let's move on to a really critical aspect. How well did forecasters predict this complex storm?
All right, the forecast challenge.
This is always a crucial area of review and analysis following any significant weather event.
It is. We learn from every storm.
And the National Oceanic and Atmospheric Administration report provides a very detailed critique of the forecasts and warnings associated with Hurricane Milton.
Okay, let's break it down.
Starting with its formation, or genesis, it seems that predicting Milton's birth was a significant challenge for forecasters.
Yeah, the early stages can be tricky.
The report is quite direct, stating that the Genesis forecast was very poorly forecast
Oh, wow.
in terms of both when and where the storm would actually develop.
So they didn't see it coming.
Initial forecasts had suggested potential development in the Caribbean Sea. And there was considerable inconsistency among the various computer weather models regarding which specific atmospheric disturbance would ultimately organize into a tropical cyclone.
So the models were struggling?
Yeah, and the proximity of a frontal system
Right.
and the influence of the upper-level winds, the westerlies,
Yeah.
added a significant layer of complexity to the forecasting situation.
Should be real wild cards.
These factors can either inhibit or promote tropical development.
Right.
And it seems they created a lot of uncertainty in the models leading up to Milton's formation.
So a lot of uncertainty in those early days.
The probabilities for development in the Tropical Weather Outlook, which is issued by the National Hurricane Center, fluctuated quite a bit during this period.
So it was a tough one to nail down.
Turning to the track forecast,
Okay.
the National Oceanic and Atmospheric Administration report indicates that the official track forecast errors were slightly higher than the average for the previous 5 years
Okay.
for shorter forecast lead times.
So not so good in the short term.
but they were actually better than average for the longer-range forecasts.
Interesting. So they got the long term better than the short term.
Overall, the forecasts generally captured the eastward and then northeastward motion of the storm. But there was a tendency for a slight northward bias in the predicted path.
So they had it going a little too far north.
Despite that tendency to forecast the storm slightly too far north.
Right.
It's important to highlight that the official forecasts did consistently indicate a landfall in the general Sarasota-Tampa Bay area of Florida's Gulf Coast.
Okay.
Which in the end proved to be reasonably accurate in terms of the overall location of the landfall.
So they got the general area, right?
Now it appears that forecasting the intensity of Hurricane Milton presented the biggest challenges.
Yeah, intensity is always tricky.
The report shows that the official intensity forecast errors were significantly higher than the average.
So they underestimated its strength.
This was primarily due to the underestimation of that very rapid intensification we saw occur between October 5th and 7th.
Right, that explosive intensification.
Why do you think the rapid intensification was so difficult to predict?
Well, the rapid intensification was likely difficult to predict due to that complex interplay of factors we discussed earlier,
Right.
such as the interaction with the frontal system and the vertical wind shear. It seems that the regional hurricane models,
Right.
which have a higher resolution and can sometimes capture smaller scale atmospheric features more effectively, they actually performed better in forecasting that rapid intensification phase compared to the official forecast.
So the regional models did a better job?
In that specific instance, it appears so.
However, the subsequent weakening of the storm as it approached Florida was generally forecast quite well.
Okay.
The National Oceanic and Atmospheric Administration report does emphasize that despite the challenges with predicting the rapid intensification, their forecasts consistently communicated the threat of a major hurricane making landfall along the Florida west coast right from the very first advisory.
So they were warning people of the potential danger.
Which is crucial for public safety.
Absolutely.
That consistent messaging about the potential for a major hurricane, even with some uncertainty in the precise intensity, is so vital for prompting the public to take necessary preparedness actions.
Yeah, like heeding evacuation order. It's all about giving people the information they need to make informed decisions.
Okay, let's talk about the tropical cyclone watches and warnings that were issued.
Okay, the watches and warnings.
For the area that ultimately experienced landfall on the Florida west coast, a hurricane watch was issued 54 hours before tropical storm force winds arrived.
Okay, that's a good lead time.
And the more urgent hurricane warning was issued 42 hours before.
So plenty of time to prepare.
Those lead times seem pretty significant for allowing people time to prepare.
They are. Those lead times are generally considered adequate to allow communities to take the necessary precautions. You know, things like securing property, stocking up on supplies, and evacuating if ordered to do so.
Absolutely. And hurricane warnings were also issued for the Florida East Coast in anticipation of the storm emerging back into the Atlantic.
Right, covering all the bases.
Which proved to be a necessary step.
It did.
The report also mentions that Mexico issued tropical cyclone watches and warnings for the Yucatan Peninsula as Hurricane Milton approached.
However, the northward bias in the track forecasts meant that some of these warnings had to be adjusted as the storm's actual path became clearer.
Yeah, that unpredictable track was a challenge.
This really highlights the challenges of forecasting a storm with such an unusual and at times erratic track.
Yeah, definitely. It kept the forecasters on their toes.
And regarding the crucial storm surge threat?
Right, the surge.
The National Oceanic and Atmospheric Administration issued both storm surge watches and storm surge warnings. For a significant portion of the Florida Gulf Coast.
Right, the vulnerable areas.
These were issued with similar lead times to the hurricane watches and warnings.
Okay, good to have that consistency.
The report notes that the area covered by the storm surge warning effectively encompassed the coastal areas that experienced the most significant surge.
So the warnings were well placed.
The forecast for the peak storm surge in Tampa Bay presented a particular challenge for forecasters due to the track sensitivity.
Yeah, track sensitivity can be a real issue with storm surge forecasting. The report mentions that even a slight shift in the landfall location, either to the north or south, could have had major implications for the magnitude of the storm surge experienced in Tampa Bay.
Absolutely. A small shift in track can mean a big difference in surge.
As a result, forecasters had to make multiple adjustments to the storm surge forecast as the track became clearer in the final hours leading up to landfall.